We are live. So today I'm going to talk about functions. So to motivate this problem, let's consider the simple problem of calculating the area of a circle. So we're going to begin by just importing pi. So from math, we're going to import pi. And maybe our radius of our circle is 5. And then our area is going to be simply equal to pi times radius squared. And then we can simply print out the area and get our answer, which in this case is 78.5. And that would be a simple calculation. Now, if I want to change this again and redo this, I could come back and maybe I want to look at the radius of 15. I can rerun the cell. But in general, when you kind of want to rerun a bit of code, it's often better to encapsulate this bit of code in terms of a function. And a function is basically what you expect it to be. Y is equal to f of x. And here we just want to use something. Function's useful basically when we want to reuse a bit of code. And we can have an input argument and an output argument. And we've already seen functions, when we've done sine and cosine and exponential. And so the basic way to write a function in Python is we use the define command. And so let's call this function area. And then we're going to have our double quotes. In this case, we have an input argument. We're going to take in the radius. And then we're going to hit the colon symbol. And that's going to define the code that defines our function. So in this case, our area is pi times our radius squared. And then what we're going to do is have our return argument, which is return area. So if I come down here, I can type print area, and I can do area 5. And then let's take print our area of 15, and I run these 2 bits of code. And the first case, I get our 78.53, and our second case, I get 706.85. So the general syntax for a function is we would define f of x, right, where x is our input argument. And then we have a bunch of code, so we'd have a bunch of code here. And the indent part, this is key in Python, is indent. Whatever's indented below this definition defines the function, and once we get rid of the indent, that's telling us when the end of the function is. So maybe this case we'll have y is 2 times x, and then we're going to just simply return the y. And so that's kind of our general function. This is kind of our y equals fx. And then I hit return. Python knows it's the end of the function because the return is typically the last argument. And so now I come back in unindented code, and I can print, I can set, y is equal to f of 3, which in this case will be 6, and then I can print out y here. And I'll get the answer 6. So again, this is kind of the general structure of a function. Now, a function need not have one argument. It can have multiple arguments. So I could do define myFun. And maybe I can take in 2 input arguments, x and y. And maybe my return argument is I'll return, x squared plus y squared. Maybe it'll be the Euclidean distance. So I'll take this to the 0.5. And so this is the distance between 2 positions, x and y, from the origin. And then now if I type myFun, and maybe I'm at position 2, 3, and that'll be my z. And then I can print my z here, and I'm going to get 3.6. I don't need the z. I can also do myFun here of 1, 1 if I want to look at a different distance. I forgot the last parentheses, and I'm going to get 1.414. So this would be an example of an input function with a function with 2 arguments. I could also extend this. I could define myFun at 2, and I could have x, y, z. And maybe I want to return the Euclidean distance in 3 dimensions, so x squared plus y squared plus z squared times to the 0.5 power. That's what I want to return. And then I can print myFun, where my x will be 1, my y will be 2, and my z will be 3. And what did I do wrong here? Oh, I used the wrong function, myFun2, and I get 3.74. Now, if I only give 2 input arguments, because it's expecting 3, I will get an error. It's going to say myFun2 is missing one required positional argument z. So it knows that the z value is not given, and these arguments are ordered based on the position. So the 1 would be the x, the y, 2 would be the y, and our 3 will be the z position. In a later video, I'll show you how to do a variable number of input arguments, but here I just want to cover the basic syntax of functions. One other thing we can do is we can actually have multiple return arguments. So let's just take in a number. Actually, let me get a couple more. So I have x, and maybe I want to return two values. So maybe I'll have z1 will be 2 times x, and z2 will be x divided by 2. And maybe I'll return both these commands, so z1 and then z2. So my return arguments are similar to my input arguments. I separate them by commas here. My return arguments I also separate by commas. If I want, I can put parentheses around this. It's not really necessary, but in this case, I'll put parentheses. And now I can print my fun of 3, and maybe I do, let's just put in 3, and then my return argument will be 2 times 3, which will be the first argument, 6, and then 3 divided by 2 is 1.5. I can have multiple return arguments as before. If I want to unpack these in variables, so I would have z1 and z2 is equal to my fun of 3, and then if I want to print z1, next line I print z2, I will get back those two different arguments. So the key thing is I have two arguments that are being returned as, in this case, a tuple or a list, right? And so z1, z2, I have to match a z1 and z2 here. If I simply said z is equal to my fun of 3, and then I print z, it's actually going to give me back, I keep on forgetting the 3 there. It's going to actually give me back both of those compounds. So in this case, z, if I look at it, it's going to be basically a list of two numbers. Technically, it's a tuple, which I'll explain later, but I have my two values. And if I want to unpack those values, I would do z1, z2 is equal to z. And then if I look at, again, my print, my z1, and then I print my z2, I get back those two arguments, 6 and 1.5. So that would be another example of doing kind of one input, two outputs. Of course, we could have 5 inputs, 3 outputs, or 5 arguments and 3 return arguments, depending on the whatever nomenclature you use. But we use inputs and outputs. So here we have 1 input and then 2 outputs. Now we can also write a function which has basically no input argument. So here I have my input of 4. If I have no input argument, I just do empty parentheses, and maybe I'm just going to return the value of 10, right? And then if I type print my fun of 4, in this case I have to put the empty quotes, right? That'll give me 10, because if I leave out the quotes, it's just going to tell me that this is just a function, my fun of 4, and here it's going to be a function, and here's kind of where it's located at. So it's just my fun of 4. It's telling me that, but if I want to get a value, I have to put the empty quotes. Now, if I try putting a value in there, it's going to give me an error because it's expecting 0 positional arguments. Let's clear this up. And so we get back our value, but we could do a lot of things here. We could also, if we could return 10, and then I can also put in a print statement. I can be returning the value 10. So a function can be multiple lines. In general, you don't want to have 100-line functions. I think I saw a posting not long ago that said like the optimal is you want under 20, trying to keep it short and simple. And you can also build up functions from functions. That's kind of your first homework. And you can combine them, reuse them, and have one function do a core operation and then another function do another operation on top of that. Finally, we can also define functions that have no return argument. So maybe we take in the value x, and maybe we're going to say, the input value is x, and I put comma here, and then maybe I'll put an x. And I can just simply end the function here. So my fun of 5, if I run it with a value 4, it's going to say the input value is 4. I could also put in text. I could say the input value is Chris, my name, so I have Chris. Sometimes if you want to make it explicit, and this is good programming style, you might just put return and put the value none here, so it has no return value. This tells you that you don't expect a return value, and nothing's changed, right? You can have it here or you cannot have it here. This just makes it very clear that you have no return value. One last thing is you can have default values for input arguments. This is often used in options, and we'll see this a lot when we start running arguments, but we've already seen it with a print function where we've used kind of the sep option where we're setting a variable in the input argument, but we don't always have to provide it. So let me give an example. So I do myFun of 6, and I do x comma y, and I'm going to set a default value of y is equal to 0. Maybe our return is going to be 2 times x plus y. I mean, if we're thinking about a linear line. And so if I print myFun, typo errors, myFun of 6, and then I put in the value 6, it's going to return back the value 12 because x takes the value 6, it's being doubled, and then we're adding 0 here because we don't have the y value, so we're just going to set it equal to 0, right? But if I print now, if I run myFun of 6 and I do 6 comma 2, now it's going to override the default value and replace the y value by 2, and I'm going to have the 14. If you want to, you can also put a print statement. You can say x is, maybe we'll make it a little bit clearer. I'll do it like that. And then we'll do print, y is, we'll assume numbers, %g, comma y. G is just kind of a generic flag for a number, kind of pre-formatted. Now I run it, and it says, whoop, got the syntax wrong. I forgot the percentage sign here. Sorry. Let's come back up here. Come back up here. Now I run it, and when I run the first time, it's when I have one positional argument saying x is 6, y is 0, and then the return value is 12. The second time, where I assign the second positional argument, now it's given 2, it's overriding the default value, and I have x is 6, y is 2, and now my return argument is 14. So this is just kind of a quick overview of functions. I put up a lot more advanced examples on Compass. I encourage you to take a look at them and play with them. If you have questions, send me, post them on Piazza, put them in the comment section. We're going to use a lot of functions in the rest of the class, but here's just kind of a quick overview of kind of the generic use of these functions. And I'll get much more later into when we decide to put things in function and in other cases where we don't put them in function. All right, that's it, and stay safe. All right, see you guys.